Okay, guys, Unit 7, Section 4, Bohr models. So we click Creating Bohr models, and this is what comes up. And it goes through a set of instructions for creating Bohr models of each of the kinds of atoms. Let me make sure this is reset, okay? And so, yeah, let's just jump into it. So first things first, step one is to use a periodic table to find the number of protons there are in an atom of the desired element. Okay. In our example, we're going to draw a model of helium. Go ahead and open periodic table here. Step two is to draw those protons as small circles with plus signs, just like I showed. So helium, I see it has two protons, because that's the atomic number, right? Matter of fact, if I click this, it'll give me an article. It might show me a Bohr model. Yeah. So helium has two protons. So that's what I'm going to draw. Boom, boom. The next step is to find the number of neutrons in the element. Okay. Again, we're going to use helium. So we're going to take the atomic mass, which here is 4.0026. We'll round that to 4. And we'll subtract the atomic number. The atomic number of helium is 2. So 4 minus 2. That gives us 2 neutrons. One here and one here. If you like, you can put the letter N inside of each neutron. I like to just leave them blank. It's really a matter of style, your preference. Okay. The next steps are to draw the electrons. So for step 5, we need to draw a larger dotted circle. It doesn't have to be a dotted circle. I tend to use a dotted circle so that we know it's not just another giant proton or something. So you're going to draw an electron shell around the protons and neutrons. And step 6 is to draw a small circle like this for each electron. We're going to put a minus sign in each one. You might use the letter E. That's the same thing. Electrons have a negative charge. I like to use the negative symbol to show it that. Okay. Step 7 is to know that the number of electrons in the Bohr model should equal the number of protons so that the atom has a neutral charge. Here I have 1, 2 positive particles, so I need 1, 2 negative particles. Now, if this electron shell becomes full, I would need to draw another shell if I needed more electrons. I only need 2 electrons though, so I'm okay. If I were trying to draw, let's say lithium, okay, lithium has 3 protons, so it would need 3 electrons. I would need another electron shell. We're actually going to see that at the end with the practice. Now, some atoms, when you try to draw each proton and each neutron, some atoms just become way too difficult to draw. There's just too many things to draw, and your drawing has to be huge for you to be able to see what's going on. So we have this simplified version of a Bohr model. For atoms that have a large number of protons and neutrons, we'll say 10, you may draw the nucleus just as a circle, like I showed here, and write the number of p's and the number of n's, the number of protons and the number of neutrons. The charge of these particles can be assumed at this point. Okay, you don't have to note that protons are positive or note that electrons are negative. And we're going to draw the electron shells as normal, okay? Because when we start to zoom out, we start to look at larger atoms, we start to focus on the electrons more and more. Okay, so here we're just going to draw the electron shells, and we're going to put E's to designate each electron. You could put these in little circles if you wanted. You might not just leave just a bare negative sign there because you might just think it's another dot. But that's just a little simpler style when you have tons of protons and neutrons. There's another even simpler style where we're focused only on the electrons, okay? And we're starting to focus really on the electron shells and how many electron shells are in the atom. The number of protons and neutrons can be assumed. If I'm talking about K here, which is potassium, I'm not really asking for how many protons and neutrons it has. This is sort of assumed. Once we get here, we know that it's 39 minus 19. So I've got 20 neutrons, 19 protons. I can say that with the letter K. We can use this model anytime we draw an atom that has more than 2 electron shells. So potassium is the smallest element I'll let you use this model for. But here are the steps. You'd write the symbol for the element, like potassium, K. I won't get into why potassium is designated with the letter K. Step 2, we're going to draw a half circle to represent each electron shell. This just saves us from drawing a bunch of great big circles on our paper. And for step 3, we're going to write the number of electrons that are on each shell. Of course, shell 1 only holds 2 electrons. Shell 2 holds 8 electrons. And the third shell holds, in the case of potassium, 1 electron. There is a third style of drawing symbols for atoms. And we might say it's a simplified Bohr model, but it's actually not a Bohr model. It's what's called a Lewis dot diagram. It just shows the potassium and it shows the electron on the outer shell, this electron right here. These other shells are assumed. We assume these when we draw a dot diagram. We won't be using this in this unit, but I wanted you guys to have seen them. We'll use these when we start to talk about chemical bonds and how atoms like to share their electrons. So now we've got some problems. Now we've got some examples I wanted you guys to do. We're going to create a Bohr model for each of the elements below. We're going to use paper and pencil. And actually, I don't need these anymore because I just went ahead and just put them in slides below. So for hydrogen, step 1 is to draw the number of protons. So I go to my periodic table. And look, here's hydrogen. It has 1 proton. The next step is to find out how many neutrons that hydrogen has. So hydrogen has a mass of 1.008. We will round this to 1. So hydrogen has 1 minus 1 neutron. So it has no neutrons normally. On average, it does not have a neutron. 8 times out of every 1,000, it will have a neutron. So for hydrogen, we're going to draw a proton on its own, and we're going to draw an electron shell, and we're going to draw the 1 electron on that shell. The next problem is nitrogen. For right here. For nitrogen, we're going to look it up. So we're going to draw 7 protons, and then we're going to find the number of neutrons. It's 14 minus 7, so 7 neutrons. 7 protons, 7 neutrons, and then we need 7 electrons. Well, this is in the second this is in the second period, right? It's in the second row on my periodic table. So I know it's going to have 2 electron shells and 7 total electrons. Okay. The number of electron shells is how many rows down the atom is. And the number of electrons on the outermost shell is which column it's in. 1, 2. We skip these because these rules get funny when we talk about transition metals. But 1 electron on the outer shell, 2 electrons on the outer shell, 3, 4, 5, 6, 7, 8 electrons on the outer shell. Here we have 1, 2, 3, 4, 5. We go to the periodic table, we go 1, 2, 3, 4, 5. The next one is boron. So let's look at boron. Boron has 5 protons Okay, and it has a mass of 10.81. We're going to round this up to 11. So boron has a mass of 11 usually. So 11 minus 5. Boron has 6 neutrons. 6 neutrons. So 5 protons. And this should say 6 neutrons. Am I looking at the wrong element? Nope. I got confused. So this should be 6 neutrons. It's still going to have 1, 2 electron shells because it is first row, second row. That electron shell, the outermost shell, is going to have 1, 2, 3 electrons on it. 1, 2, 3 electrons, but it's going to have 5 electrons total. Because again, the first shell holds the first 2. The next problem is lithium. I said we'd talk about lithium. Here's lithium. We go to the periodic table. It's got 3 protons. It has 7 total particles. So 4 of those are going to be neutrons. 7 minus 3 is 4. So we got 1, 2, 3 protons. We have 1, 2, 3, 4 neutrons. Again, lithium it's going to have 3 electrons, and the first shell only holds 2. So 1, 2. We need a new shell, and boom, here it goes, 3. The next element is sodium. So we go to sodium. Sodium is 1, 2, 3 layers down. Okay. So sodium's pretty big. So we don't have to draw the protons and neutrons anymore when we're doing sodium. We don't have to draw those. It has more than 10 total. Actually, boron probably counted. We probably didn't need to draw the protons and neutrons. So we just say 11 protons. We go do the math. We do 23 minus 11. That gives us the number of neutrons. Sodium has 12 neutrons. Sodium's on the 1, 2, 3rd row, so it's going to have 3 shells. 1, 2. Sorry, it won't let me click the middle. 1, 2, 3 shells. And then it's going to have 11 total protons. So shell 1 holds 1, 2. Shell 2 is going to hold 8. 1, 2, 3, 4, 5, 6, 7, 8. And then it needs that 11th electron. 11 protons, 12 neutrons, 3 shells with 11 electrons on them. I can tell just looking at the periodic table, though, that sodium has 1 electron on its outer shell. That's why it's in this first column right here. All of these elements have 1 electron on their outer shell. All of these elements, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, all of these have 3 electron shells. The next element is carbon. So we look at carbon. It is it's in the 2nd row here, the 2nd period. And it is 1, 2, 3, 4 over. So I know automatically that it's going to have 2 electron shells. It's going to have 4 electrons on that outer shell and 6 protons. So here we go. I think these are out of order. It's going to have 6 protons. I do the math. It has a mass of 12. So 12 minus 6 tells me that there are 6 neutrons. And just like I predicted, because carbon is in the 2nd period, the 2nd row, it has 2 electron shells. And just as I predicted, because carbon is in the 4th column or the 4th group, it has 1, 2, 3, 4 electrons on its outer shell. Plus the 2 in here, that gives us 6 electrons to match our 6 protons. go back to neon. I skipped over neon. I apologize. Neon. We look at it on the periodic table. It's got 10 protons. 20 minus 10 gives us 10 neutrons. It's going to have 2 shells. And it's going to have 1, 2, 3, 4, 5, 6, 7, 8 electrons on that outer shell. Plus the 2 in here gives it 10 total electrons. 10 protons, 10 electrons. Hopefully this helps us understand why groups and periods are arranged the way they are. We had one last problem here, and it's argon. Argon. I was going to tell you guys some chemistry jokes in this lesson, and I was looking for my notes, but they are gone. Sorry, I'm not proud of that. Okay, so argon, here it is. Now argon, we can tell it's got a mass of 39.948. It's got a huge mass. So it's got lots of protons and neutrons. It has 3 electron shells. We don't need to draw all that anymore, right? So it's good enough to just say argon and then to tell about the electrons. Okay, to tell us about the electrons. So here we go. Here's argon. Okay. Argon. Now, we can do the math. We can find out how many protons and neutrons argon has. You can see here it has 39.9, so it's got 40 total. 18 of those are protons, so 40 minus 18. It has 22 neutrons. It has 18 protons. It's going to have 18 electrons. But when we're talking about atoms this big, we're usually talking about the electron shells. So we really just need to say it's got 2 and then 8 on this shell and then 8 more on this shell. And so this style number 3 Bohr model is good enough for argon. So those are the rules for creating a Bohr model. Usually I will be asking you to create Bohr models of atoms like nitrogen and carbon, maybe oxygen. And those aren't very big. They're these ones right here. They're kind of the ones that are hard enough to draw that it shows that you know how to draw a Bohr model, but they're not so hard to draw that you're spending all day drawing little plus signs. Now, I have created a periodic table of Bohr models, and it goes pretty far. It doesn't cover every single element on the periodic table, but it goes all the way to calcium, which is all the way down here. And at this point, we start getting into the transition metals, and Bohr models don't make a lot of sense for us when we talk about transition metals. So in my periodic table of Bohr models, I stopped at calcium. And you can see that, well, here's potassium, for example. We can see how many shells we're talking about. The rules for how atoms bond start to change when we talk about atoms that are much bigger than this. So for a high school physical science class, we won't really talk about models of transition metals, models of these. Okay, scandium to mercury. But using my periodic table of Bohr models, you can see the progression of each atom. So we've got 1 proton, 2 protons, 3 protons, 4 protons. Okay. And as they get bigger and bigger, you get more neutrons, you get more electron shells, those shells fill up, you get more electrons on those shells. And this is why the periodic table is arranged the way that it is. Hydrogen, you can see it here on the table. Helium, you can see it next. Lithium, we go down to period number 2, second row. Period 2 has 1, 2 shells, right? It's in group 1, so it's got 1 electron on its outer shell. Beryllium, next to it here, it's going to have 2 electrons on that outer shell. The next one's going to have 3 electrons on the outer shell. 4, 5, 6, 7, 8. And now this shell is full, and we're at the end of our periodic table. So when we go to sodium, we will need an additional shell. Boom, there it is. And it starts to fill up 1, 2 electrons, 3 electrons on the outer shell, 4. And at this point, I've transitioned and started to show you the different model, the style 3 model. Okay, we're just saving time. Okay. So this is Bohr models, and this is how you create Bohr models, a step at a time. Sorry, I guess it's this slides. Bohr models a step at a time. On the test, you will be asked to draw a couple of Bohr models, and I will decide how we will accomplish that online.